Convergent Plate Boundaries by Robert Geis. Today we're going to be talking a little bit more in detail about the Cascade Mountain Range and its convergent plate boundary characteristics. But first, let's go over a brief diagram of what is a convergent plate boundary. Well, as you can see here, we have one plate, which in our case is the Juan de Fuca plate, which is actually subducting underneath the North American plate, which is right here. So as this is happening, there's a lot of things going on. We have compression stress, which is causing earthquakes deep below the surface and bringing it all the way up to the top. We have mountains that are being folded. We have volcanoes that are molten lava is coming up through the surface. There's a lot of big stuff going on here, you guys. So let's look further. So real quick, a brief overview of what the Cascade Mountain Range is and where it is exactly. So it runs from southern of British Columbia in Canada, goes all the way through Washington, through Oregon, and all the way through northern California. And so what these mountain ranges are, what they kind of look like, is almost like a granite marble almost. And so this mountain range consists of non-volcanic mountains such as the lower Cascades and volcanic mountains, which are the higher Cascades. But we'll get to the volcanoes here in a minute. But these are just a couple of pictures of what the mountain range actually consists of. It's beautiful. So earthquakes definitely occur at convergent boundaries, and this is from compression stress. When you put two plates together and one's actually sliding underneath, these plates are not exactly smooth and they're not rounded, so they don't just slide really smoothly together. They kind of stick. And so when that happens, we have stress that builds up, and once enough energy builds up behind that, it's then released, causing an earthquake, as you can see in these subduction zones right here, and then also deeper, further along the Juan de Fuca plate. And so once this smaller plate gets further underneath the North American plate, it then, part of it starts to actually melt. But we'll get into that in a little bit. And so this is just another diagram giving you an idea of what's actually happening along the coast of California, Oregon, Washington, all the way up into British Columbia, Canada. And so what we saw earlier was the little Juan de Fuca plate is being subducted under the North American plate. As this happens and that smaller plate goes further and further underneath, fluids are released from the plate, causing part of that crust to actually melt. The new magma then rises and may actually erupt to form volcanoes, which brings me to this beautiful thing. Well, this is Mount St. Helens. She actually erupted back in May of 1980. It was one of North America's most geological disasters, biggest geological disasters. So yes, volcanoes definitely occur at convergent plate boundaries. And so earthquakes also occur at these types of plate boundaries, but I want you to take a look at the picture on the right. Or it basically looks like a car got into a crash and all the metal's kind of crinkled up and kind of folded up. Well, ironically, that's kind of what's happening right here. This is actually a diagram of the Cascade Mountain Range. So it's kind of all folded up because we have compression stress where there's nowhere else for the plates to go. So it causes the rocks, aka the mountains, to actually fold or buckle, creating these ridges and creating these little valleys that you see in these peaks all along here. And that, my friends, is a little bit about the Cascade Mountain Range and the convergent boundaries characteristics. Thanks so much.